This video is meant to help you make sense of the warm-up problem that you did. Hopefully you tried to factor it and find some factors. This one's a little bit tricky because it requires you to recognize a few of the factors that maybe you wouldn't have noticed. Yes, you can use generic rectangles or long division to test different roots, but we want to try to use some more sophisticated strategies like you're learning in class. So one of the ideas that we want to think about here is that we could make a list of all the potential zeros, the rational zeros. And we always look at the constant term and we think, okay, what are the factors of 4? 1 is a factor of 4, 2 is a factor of 4, and 4 is a factor of 4. So my potential roots could have a numerator of any of these values. Okay? Those 3 potential values. Positive or negative 1, positive or negative 2, and positive or negative 4. Then we look to our numerator to find the possible values for the denominator. So the roots could have a denominator of the factors of 2, which are 1 and 2. Okay, so think about this. Our possible numerators are 1, negative 1, 2, negative 2. And they can be divided by these different denominators. So what we have is a long list of numbers. Well, let's think about it. 1, anything divided by 1 or negative 1 will just be that number its opposite. So my true list includes plus or minus 1, plus or minus 2, and plus or minus 4. That's if I divided them by the 1, if the denominator was 1. Now, what if the denominator was 2? Well, let's see. If the denominator was 2, if I did 1 divided by 2, I would get the different values of plus or minus 1/2. Okay, those are the potential roots. Now, what if I did 2 divided by this denominator? Well, 2 divided by 2 will be 1, or negative 2 divided by 2 will be negative 1. So we've already included those right here in the plus or minus 1. The last one I want to consider is what if I did this numerator divided by 2? Once again, we've already considered that in these terms. So this is my complete list right here. These 4 pairs is my complete list of potential roots that I want to test with synthetic division. Okay, this 1/2 is probably the most problematic because we wouldn't have thought of that. But it could be true that my factor could be x minus 1/2 or x plus 1/2. That is a potential root that would work here. Okay? So maybe you tried 1 or 2 or 4 with synthetic division. Maybe you tried generic rectangles. But the actual factor that we're going to try is the 1/2. We're going to see if 1/2 is a root. 1/2, not the easiest thing to multiply by, but not impossible either. So we're going to write it out just like we would normally with synthetic division. It's okay to have a fraction for c. Okay, it's not okay to have a coefficient on x, but it is okay to have a fraction for c. Let's see, I'm going to drop the 2. Multiply 1/2 times 2, I get 1. Negative 5 plus 1 is negative 4. Multiplying 1/2 times negative 4, I get negative 2. Adding negative 6 and negative 8, I get negative 6 and negative 2, I get negative 8. Once again, multiplying negative 8 times negative 2, I get negative 4. And it appears that 1/2 is in fact a root of this polynomial. So I have a root of my polynomial. I can write my polynomial as x minus 1/2 times 2x squared minus 4x minus 8 equals 0. Because negative 1/2 was a root according to synthetic division. So now I have to continue and I have to factor this guy further. Well, one good thing I see is I see a common factor. So it looks like I can rewrite this second factor as 2 times x squared minus 2x minus 4. That helps me work with some smaller numbers. Okay? So 2 is another factor. It doesn't affect my solutions to this problem. So I still need to find the solutions that appear in that quadratic. At this point, I'm going to use quadratic formula because nothing pops out at me and I can guess and check and continue trying my different roots that I listed here. But I'm going to try the quadratic formula. Opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 So it's like we get 2 plus or minus the square root of 4 plus 16 all over 2. So it appears my additional roots are going to be irrational. And that's okay. We can still find our additional roots. There's still decimals. They're still important. There's still solutions to this equation. There's still solutions to this guy when this guy is 0. So one solution is going to be 2 plus the square root of 20 all over 2. And the other solution is 2 minus the square root of 20 all over 2. Okay, and my final solution was what I saw here, 1/2. So I have 3 solutions. 1/2, 2 plus square root of 20, 2 minus the square root of 20 over 2. These are not proper over here because they're not fully simplified. So I'm going to take a moment to simplify them. Let's see, I'm going to separate the denominators. So it's going to be 1 plus the square root of 20 over 2. Or 1 minus the square root of 20 over 2. But it looks like square root of 20 has a perfect square in it. So this is equal to 1 plus or minus the square root of 4 times the square root of 5 over 2. Square root of 4 is just 2. So those 2's will cancel. So the correct solution is 1 plus or minus the square root of 5. Those are the other 2 solutions in proper form. So they're much simpler than what we saw originally over here. They're simplified because the radical's taken out. But the 3 solutions you would want to give on a test are 1/2, 1 minus the square root of 5, and 1 plus the square root of 5. So pay close attention today. Make sure that you're actually simplifying properly and getting the exact answers that you see in the back, because those are proper form answers. So when you're solving a polynomial, you're looking for the factors, and synthetic division will help you do that. So once you factor it, just like is hinted at in this problem here, once you factor by using synthetic division, you might have to, number 1, keep in mind the potential fractional factors, okay? And also keep in mind that you might have irrational factors like we saw down here. So once you get to the stage where they're quadratics, make sure you keep that in mind as well. But sometimes you might want to use generic rectangles or long division. So good luck, and make sure you get your assignment done by tomorrow. Friday.